Equation of tangents from outside point. Find equation of tangents to the parabola y equals to x squared plus 2x that passes through the point 1 minus 6. Now this question is kind of unique in itself. What we have here is a function which represents a parabola and then a point which is not on the function, it's outside. It's kind of like this. The situation is like this, that we have a parabola here, and as you can see, the parabola is y equals to x squared plus 2x, where if you factor out, you get x times x plus 2, right? So that means it has got two roots, which is one here and the other one at x equals to minus 2, right? So it's kind of a parabola which is, let us say, kind of like this, right? And if we have a point is 1 minus 6 somewhere outside here. So what we're trying to say here is this, that from this point, which is outside this parabola, you have to draw a tangent line to this curve. So it's kind of like this on this side, and then similarly we can make one on this side. So that is your point, which is given to as 1 minus 6. So this point is outside the curve. So from here you can draw two tangents to the function, and we need to find equation of both these tangents. So I hope you understand what the problem is. Now, how to solve such problems? So one way is that, let's assume that this point on which this line is tangent is Q, and at this point the value will be, x of value will be, let it be a general value. So a value is for x. If x is a, then y will be a squared plus 2a, right? A squared plus 2a. So that is going to be the value of coordinates at point Q, and this is the given point P to us. So what is the slope between these 2 points? y2 minus y1 divided by x2 minus x1. That is one way of calculating the slope. The other one is that on any function we can find the first derivative, and at that derivative, if we put x equals to a, we get the slope of the tangent at that point. Now we can equate these two and then solve for a to get the value of a. So that is a strategy which we are going to follow here. So let's assume that the point Q on the function is a, and since x is a, y value will be a squared plus 2a, right? A squared plus 2a. That's the point Q for us. And point P is given to us as 1 minus 6. So what is the slope between these 2 points? Let's say slope BQ will be y2 minus y1 divided by x2 minus x1. Now you can take any one of these points as y1 by 2, right? So let's take these values as positive. So we get a squared plus 2a minus this, minus and minus becomes plus, divided by a minus 1. So that is the slope between points P and Q. Now we also know that the function is y equals to x squared plus 2x. Let's call this equation as 1, okay? Now y dash will be equals to 2x plus 2. Now if y dash at x equals to a will be what? At x equals to a, y dash will be 2a plus 2, correct? Now we already know that the slope at this point is actually given by equation 1. Now this is also the slope at any point a, x equals to a on the curve. So these two should be same, correct? So now we can equate them and then expand. So we can write the slope MPQ is equals to y dash, right? And therefore we can write now a squared minus 2a, sorry, this is plus 2a, a plus 2, right? So a squared plus 2a plus 6 over a minus 1 should be equals to 2a plus 2, correct? So that becomes our equation in one variable, and that is a. Now from this equation we can always solve for a. So let's do that. So we'll cross multiply and then solve for a. So we have a squared plus 2a plus 6 equals to cross multiply. So we get 2 times okay, 2 times, let me write a plus 1 here. I'm factoring out 2 and then times with a minus 1. I've done it on purpose. It is sometimes difference, right? A plus 1 times a minus 1 is a square minus 1. So it's easy to expand, right? That's correct. Now, so we have a square plus 2a plus 6 equals to 2 times. This becomes a square minus 1. Now we'll bring all the terms to the right, and so we get 0 equals to, this is 2a square minus a square gives us a square. And 2a when it goes to the right becomes minus 2a. 6 will become minus 6, and here we have 2 minus 1 is minus 2. So we get minus 8. Now this can be factored. Sum of two numbers should be minus 8 and product minus 2. So the numbers could be a minus 4 times a plus 2, right? So when you do this, then you get the same expression. So this is equal to 0 for a equals to 4 or for a equals to minus 2. So these could be two values of a. So that means this side will be a equals to 4 and that side it will be a equals to minus 2, right? So if I write, this side will be minus 2 and that side will be 4, right? So this is minus 8, so minus 2. So if a, let me write it on this side. Or let's do, if a is 4, then what is y equals to? So we give, this is the value of y. Let's call this equation 3. So if a is 4, y value will be equals to 4 square plus 2 times 4, which is, let me write, 4 square plus 2 times 4, and that gives us 16 plus 8, which is 24. And in this case, y will be equals to minus 2 square, right? This value, a square plus 2a, right? Plus 2 times minus 2. That means 4, and 2 times minus 2 is minus 4. That means 0, right? Y value is 0 for this place. So f of minus 2 is 0. So the points for us are 4 and 24, and here we get minus 2 and 0. So this is almost here, minus 2 and 0. So these are the 2 points on the function where the tangent from P will be touching the curve, right? Now what we need to find is the equation of tangents to this parabola, right? Now you can find the equation knowing the slope and y-intercept. So we can use the slope at, now y dash is 2x plus 2. Let's call this. So y dash is 2a plus 2, equation number 2. So we can put the value of a here and find y dash for both. So let me use a different ink here. So y dash is equals to 2a plus 2. A is 4 for us. So 2 times 4 plus 2. That gives us a slope of 8 plus 2, 10. When we have this line, when x is 4, so that means this side. And for the other line, y dash will be equals to 2 times a plus 2. So 2 times a is minus 2 plus 2. That means minus 4 plus 2, which is minus 2. So slope is minus 2 for the other line, which is this negative line, okay? Negative slope minus 2 and positive slope of 10. Now we know the slope and we know a point on this line. Rather we can use 1 minus 6 also. And knowing the slope and the point, we can find equation of the line, correct? So let's do that part. Let's find equation of the line now. So what we have found is there are two different points, and so there will be two different equations, right? One we know is the point which is on the left side, Q, where the point is minus 2, 0. That's the point, and the slope is equals to minus 2, right? So that is the slope for this line. Therefore, the equation will be y equals to mx plus p, which is minus 2 x value is minus 2 plus b. We need to find, so first let us write equation y equals to mx plus b, and then we'll substitute slope y and x points and find the point b over here, right? So we get this as, the point is 0 and minus 2, slope is minus 2, so we can write 0 equals to slope of minus 2 and x value is also minus 2 plus b. So b gives us a value of minus 4. Therefore, equation of this line will be y equals to minus 2x minus 4. And for the first line, the equation should be, so we have here the slope of, well, this is a point with 4, right? So the point is, let's write q dash is 424. And the slope is m equals to 10. So if I write y equals to mx plus b, I get y is 24 equals to slope is 10 times x is 4 plus b. And from here, we get value of b as 24 minus 40. So b is equals to minus 6 and 16. b is 16, and therefore equation of this line will be equals to y equals to slope of 10 x minus 16, right? So these are the two lines which are tangent to the curve from external point P, right? So these are the two lines. So that is how we can get equation of tangents from an external point, okay? So let's go through this process once again. Now what we did here was that we assumed that let the point P with x equals to a on the curve, where from the external point we form a tangent to the curve. Then the slope will be y2 minus y1 divided by x2 minus x1. So that is one slope. Second, we know derivative of a function gives you the slope. At a, the derivative will be 2a plus 2. Then you equate these two slopes and find the point a. So with that, we found 2 points. So a equals to 4 and a equals to minus 2 are the points on the graph, which will give us two tangents from the external point 1 minus 6. And at these points, we calculated slope from the given formula. The slope at 4 was 10, and the slope at minus 2 was found to be minus 2. So these are the two slopes which we calculated, right? And then we used those new points with the given slopes to find equation of line. You could use the point 1 minus 6 with these slopes to find equation of the line, and that could have been your answer, right? So that is how you can solve these questions. Okay? So I hope the method is clear to you. Go through it once again, try to understand. But the key figure which I want to point out here is that when you read a question and when you read tangents, that means there are more than one tangents, and that is only possible when the point is not on the curve but it is an external point. So when there is an external point, then you follow this method. Okay? Thank you.